So I'm the product manager and head of R&D for the NFV products at Enea. And today I'm going to provide you some information about our strategies around UCB and platforms for UCB and how to deploy UCB on a constrained type of hardware environment. So just a summary here. So first off, we see that UCB deployment is happening now at scale. There's a lot of interest in the market for deploying UCBs and a special focus on SD-WAN as a first use case. It is great because the UCB and the SD-WAN solutions out there that we are working on and others are working on are true to the NFV principles, meaning that you can build solutions based on different vendors, best of breed, and create integrated solutions without lock-in and open solutions. And nowadays it's also possible to get the economics working, meaning that you can have the right cost structure for deploying UCBs. So Enea, we're a company of 50 years plus, and we are all focused on software. We are a independent software vendor, and we're trying to be true to the VNF principles, meaning that we are focusing on one of the layers with our products, and we are creating independent products that can be combined into different solutions for NFV. And we have a big footprint in telecom, as you can see here on the slide. So the Enea portfolio is kind of big and it's growing. A lot of the focus and the DNA of the company is around operating systems and embedded systems, but we're also expanding into traffic intelligence, traffic management, and application space with different acquisitions. But today we will talk about our platforms that are more centered around operating systems and operating system solutions. As you can see, we also have a services organization and so on. So it's a broad approach. So here's an example of a configuration and a solution that we are working on, and there will be some focus on this in this presentation. So Enea working on the platform level, virtualization platform level for UCBs. We are providing that layer, but we're also partnering with hardware vendors for white box hardware solutions, with VNF vendors to provide the application, and also in some cases orchestration vendors to build the full managed stack. And we want to be true to the NFV by providing solutions that are zero lock-in and open. That allows the customers to pick and choose what white boxes, what VNFs, what orchestration solutions that they need according to their use cases, so that you can build best-of-breed type of solutions. And allow the customers also to have a dynamic approach, meaning that they can change hardware platforms or VNFs or orchestration or whatever layer in the solution according to their needs in the future. Right. So here is a bit of a case study. So we're working with an operator in EMEA. They are targeting a wholesale type of SD-WAN story there, and we are working on the UCB side. And in this case, we're talking about the lowest end of the spectrum here in terms of hardware. So here we are providing a solution that allows the customer to run on a really low-end hardware platform and provide an entry-level type of SD-WAN solution, where you basically create connectivity with SD-WAN with a single entry box, and this becomes a UCB with a purpose. So it's not a compute node per se, it's more of a purpose-built UCB with all the advantages of management and virtualization in there. So the requirement from the customer is really that they want to have a variety of VNFs to choose from and allow their customers to choose VNFs. So this is, of course, coming back to the true meaning of NFV, being able to pick and choose and choose their layers. They want to be able to choose hardware and replace hardware. So they need to have a white box strategy, or there has to be a white box strategy here that is working and independent of the other software layers. And of course, automation and control and user experience is important because in the end, there's an end customer that needs to use this, and it has to be efficient in terms of operation as well. And in this case, we are working together with Advantech and Fortinet to create a reference solution here, which is illustrated by the picture. So basically, you have the UCP here with a number of LANs and LTE and a shared WAN port for management and for data traffic. Okay. So how do we achieve this packaging, and why is it cost efficient? So it's built on the layers. So first off, the hardware. So we are able to run this solution on a 2-core Celeron with 2 gig of RAM, which is quite good because, as you all know, RAM memory is a cost factor. And if you can reduce the amount of RAM, you can also reduce the cost of the hardware spec. So in order to do that, Enea is working on this NFV access platform, which is basically an operating system based on Linux that we have built from the bottoms up, optimized for minimal footprint and networking efficiency in a virtualized environment. So what we are doing really is basically removing everything from a typical Linux system and adding optimizations to the Linux system in order to make the platform as small as possible and dedicated as possible to the purpose of it, to be able to virtualize VNF and to manage those VNFs. One other important strategy here is the netconf aspect. So a lot of our competition is trying to take data center software and push it down to the UCP so that basically they can enable that kind of functionality in the UCP. We took a different approach because OpenStack, for instance, is quite kind of complex piece of software and maybe a little bit of an overkill for the UCPs. Instead, we are building our own management stack on netconf, which really reduces the footprint of the platform and improves the efficiency of the networking. So on top of that, we also need the application. So here we are working with Fortinet. So 2 important factors for this type of deployments is you want to have a secure solution with a good firewall, and you want to have a proper SD-WAN connectivity. And the great thing about Fortinet is that they combine this into one VNF. So in this type of system where you only have 2 cores and very limited RAM, it's an advantage to have a single VNF that can satisfy the whole feature set that you need for the platform. And Fortinet is also quite low footprint. So we're able to squeeze this all in on the 2 gig RAM deployment. And of course, there's a manual side. You also have the management system. So we are also, Enea also providing the Enea UCP manager, which is basically a VNF manager for taking care of the VNFs and the platform and managing that either connected to an orchestrator or as an independent software component in the manual stack. All right, so the Enea NFV access. This is a picture that tries to illustrate how we deploy. So basically, it's 2 distinct components. One is the platform itself that runs on the UCP, and one is the UCP manager that runs in the cloud somewhere and connects to the orchestration framework of the customers. And all the management traffic in between the NFV access and the UCP manager is netconf based, which is great because it's a secure link and it's an open protocol. And it's very efficient from a footprint perspective. The Enea UCP manager, it provides pretty much all the feature set that you need in order to do the provisioning, zero-touch provisioning, and all the management of the platform, including software upgrades and such things, and VNF management and VNF lifecycle. And that, in its case, has a northbound REST API that connects to the rest of the manual stack, so for instance, orchestration. And this is really the way, so this is really the layer of the virtualization platform that we provide, and then we can deploy with any white box, with any VNFs that the customer asks for. So it's great because we don't have a requirement on what orchestration solution that the end customer requires. So with the REST APIs and the openness of the platform, we're able to basically integrate with the customer's orchestration choice. All the management over netconf is also great, security, openness, and also the fact that it's lightweight and scales well. Simplicity of the VNF onboarding is of course a key component here, because you want to have customers that can onboard new VNFs as they come and satisfy the customer's needs over time. And we have the white box hardware choice there. So here are some details about Enea NFV access. I will focus on a few things here. So in order to get the right networking performance, you really have to utilize the hardware accelerators of the white box. Enea NFV access is based on DPDK and OVS DPDK for networking and switching. And there is, of course, a lot of work being done on optimizing these components for the special purpose and connecting it to the virtualization in KVM and Docker. The SRIOV here in the picture, and also PCI pass-through, represents a great way for the VNF to avoid the overhead of switching inside the platform and take the traffic directly into the VNF. So we are enabling that for customers and allowing them to combine vSwitch for chaining, etc., and SRIOV or PCI pass-through to maximize the networking performance of the VNFs. Right. We also have the FCAPs and netconf here, so we already touched on that. We have the netconf protocol for management, but you can also use that netconf component to create custom FCAPs, which is important in many cases. So also the FCAPs component can be adapted to specific use cases if a customer wants to adapt and add more to the FCAPs feature set. Okay, so here's a picture that describes some of the characteristics of the platform, and we are comparing to, we call it alternative commercial, competing commercial alternatives. So we are looking at OpenStack type of competition. So first line here, the RAM footprint. So we can squeeze the actual platform into less than 1 gig of RAM. And then we can devote the rest of the memory for the VNFs in the system in order to optimize networking traffic and to run the VNFs in a virtual machine. In competing solutions, we know that OpenStack consumes quite a lot more, and this has a big impact on the cost of the hardware. Disk footprint is pretty much the same. We have a really small footprint as a consequence of the fact that we have optimized the RAM footprint. So everything gets squeezed down when you remove things that you don't really need for the UCP platform. Again, OpenStack consumes more memory in the disk. We are also able to dedicate the platform to a single core and use core isolation to provide capacity to VNFs with the rest of the cores of the system. So also the size of the CPU or the number of cores of the CPU is really limited here. So the minimal deployment would be to have 1 core for the platform and 1 core for the VNF. And of course that can scale up. So if you want to have a more capable solution, you can have more cores dedicated to the VNFs. And same goes for the RAM, of course. Another interesting thing that we have been working on is the boot speed. So when we started to look at this platform from the beginning, we really focused on the characteristics first. And we saw boot speed as a characteristic for creating resiliency in the user experience. So if you can reboot fast, you're able to minimize the downtime of the system. For instance, if you do a systems upgrade or recover from some kind of a fault. So we really optimize that as well while doing the RAM footprint optimizations, reducing the platform from booting the platform to actual service to less than 3 seconds on a typical Intel hardware platform, which is of course an important parameter. And then on the networking side, we are able, despite the fact that we have such a limited hardware platform, we are able to satisfy 1 gig, 10 gigabit type of line rates. With the platform. Of course, it all depends on the hardware platform, but in the minimal set, we can do the 1 gigabit line rate performance, and with a very good latency as well. So this are really characteristics that we believe are fundamental for building a good UCP solution for the lower end of the spectrum. Right. So the UCP manager, that's the manual side of the solution. That's the VNF manager. It provides a lot of the functionality. Basically, it provides enough functionality on the manual side to manage a set of UCPs deployed in field over netconf, and it's extendable, so customers can add modules to the UCP manager if they are extending the FCAPs, for instance. It does all the lifecycle management of the platform, of the VNFs, all the onboarding, etc. And in addition, it's taking care of provisioning of the platform as well. So it's doing zero-touch provisioning according to the new call home RFC for netconf, for instance. And in order to create an alternative to using the graphical user interface, we are also providing scripting on top of the UCP manager. So for instance, you can use Python scripting or Ansible scripting to automate the operations of the UCP manager feature set. So everything in the UCP manager is exposed with REST APIs. So you have all the ability to either integrate with an orchestrator or with the REST APIs, or building automation scripting directly on top of the UCP manager to create a good user experience and a good experience for operators using the system. Right. So some takeaways. It's kind of repetition. Deployment is happening now on a global scale. So we see interesting opportunities in Europe, Americas, Asia. Everyone seems to be interested in deploying SD-WAN solutions, and especially when it comes to lower end on the hardware spectrum, there's a lot of interest. There is enough now of solution that you can build this type of best breed solutions. There's a variety of VNFs available, a variety of white boxes and orchestration solutions. Of course, the key factor here is to create great integrations of these components. And there's a role in here for that with the systems integrators. But the catalog is available. It's just a matter of finding the right pieces and combining them. And we believe that we provide an important building block in this solution. Based on open source or based on openness is of course very important and true to the NFV goals. And I think the economics are now in place with the fact that we can squeeze down the solutions to really small hardware specs. We're now able to satisfy the needs of CapEx so that you can have a solution that actually is beneficial for the operators using it. So with 1 minute to spare, if there are any questions.
You actually have more time, about 4 minutes.
Not according to... Okay. So are there any questions? Well, thank you first. And are there any questions? Yes?
How do you stack up according to your competition?
How do I stack? So what do you mean by that?
I don't know. Just I always used to with nobody else.
Yes. So to be quite frank, so I think this slide says a lot. So I think
Is there anyone else in this low range?
I would say that most of the competition is in this field, right? So they are building on the OpenStack and they're requiring more hardware. When it comes to the lower end, I think I would say maybe in-house type of implementation can be a competition. But in terms of commercial solutions, we haven't really found a lot of competition.
Okay, that's what I thought.
Yeah.
Thank you.
Any more questions?
About the VNF onboarding, you mentioned that you use netconf for the VNF onboarding and REST API to the external world. Does it mean that if you want to onboard another VNF other than the one that you mentioned, do you need the VNF supporting netconf, or are you, let's say, open to support different protocols, interfaces?
So I believe the question is how we support different VNFs or how we onboard.
How you manage the onboarding?
Yeah.
of other
So
VNFs?
right now we are using a special syntax for VNF descriptors and the configuration of the VNFs, but we are transitioning towards standards-based VNF descriptors and onboarding. So right now, in order to deploy, you have to create a special bundle of the VNF containing the configuration of the VNF and the flavors of the VNF, and that's what you onboard. So there's some work to be done, but it's not a very complicated process. So we are basically repackaging the VNFs that we are supported to allow them to run on this platform.
Thank you.
Anything to say to security more?
Yeah, so on the security side, so we are of course aware that there's a lot of need for security, and a lot of the problems with security are really solved by the fact that we are using netconf. So netconf, as you probably know, runs over encryption over SSH. So all the management traffic is secured by design, but we are also of course implementing secure boot, and in some cases we're actually adding SC Linux and SVirt in other use cases where there is more openness to an onboarding of the VNFs. So in some cases, the customers see that need and we are deploying that, and it's not really impacting our characteristics that much. So that's really the strategies we have, on top, of course, of patching the platform based on security issues reported publicly. Yeah.
And DNS as well?
Only is more software thing. Yeah, I think I retire.
I withdraw the question.
Okay, thank you. Thank you. All right. Are there any other questions?
Yeah.
Very quickly.
There's blinking.
Okay. Yeah. Which white box vendors does Enea support, and how do you see white boxes versus gray boxes?
Right. So a lot of we see a lot of companies that has been using gray box type of solutions from various. I guess that's also competition. Basically, one single vendor providing the hardware, the platforms, the VNFs to provide these kind of solutions. But we also see a trend of people going away from the gray box solutions into more white box in order to get an economics right in this model and have the ability to pick and choose. And we are working with companies like Advantech, with rner, with Contron, and there's a variety of different white box vendors that we actually support. And the great thing about, in this case, Intel is that it's quite easy to add more hardware platforms. White boxes are standardized, and it's easy to port the platform on top.
Great.
Okay. Thank you, guys.
Karl.